Before we jump into how Synchro can be used in the AWP environment, I want to take some time and go over the Synchro ecosystem. Traditionally, most people know Synchro as a 4D scheduling tool, which is still a large part of the Synchro suite. But Synchro has grown into a lot more. It is now a full project management solution with web, mobile, and cloud-based applications. The three we are going to concentrate on today for the AWP applications are Synchro Field, Control, and 4D. Synchro 4D is our cloud and desktop planning and estimating tool. This is the traditional Synchro tool most know. It allows us to link our models to our schedules and give us the ability to look into the future of our construction projects. We can run simulations and comparisons to ensure we have the best and safest plan possible before actual boots hit the ground. Along with this comes Synchro Modeler. That allows us to break up models into more workable sections and do model-based quantity takeoffs. Next, we have Synchro Control, our web-based project management and document control tool. Control is the heartbeat of the Synchro ecosystem, creating a direct connection between 4D, Control, and Field, generating that direct link of communication between the office and the field. Control is equipped with map and modeling services to help pinpoint issue and RFI management, as well as custom inspection and digital forms that are linked to an interactive dashboard. Synchro Field is our mobile field management solution that can be used from a tablet or a phone. It allows your team in the field to access and mark up documents, fill out digital forms such as issues, RFIs, and daily logs. Field brings the work plan to the field and allows mobile-based progress tracking. If your construction project doesn't have internet access, that's fine. This can all be done offline if needed, and synced back to Control once you're back to internet connectivity. I will point out Synchro Cost, our cost and procurement management tool. Also, Synchro Perform, our project performance insight tool, developed from the acquisition of E7. Both are coming soon and due to be released shortly. Alright, so today we're going to talk about the implementation of Synchro in the AWP space. If we take a look at the top half of the workflow, that's our traditional 4D, 5D planning workflow, which basically takes a model and links it to the schedule, giving us a visual look into the future of our project. Adding AWP to this workflow allows us to put more governance on how we organize the planning of our projects, how we break it down into work phase planning, also how we would implement the look-ahead planning and constraint analysis within the Synchro application itself. So when we do the look-ahead and constraint analysis, we want to identify the packages that are not ready for the field. So today we'll take a look at the 11 steps of this process. First, we will want to produce the path of construction, the optimum sequence of tasks to complete the project. Once we have that, we can set boundaries of the EWPs and CWPs. Next, we can start extracting the IWPs and link them with the checklist items. Now, we can identify the should and start our look-ahead planning, which will kick off the constraint check, ensuring all the required drawings, labor resources, equipment, and materials are added to the packages. Now, we can issue the CAN and start approving the IWPs. Once all our IWPs are ready to go and the work starts to be executed, we will need to start tracking the progress. With that comes field and task management, where we start to deal with issues, as-builts, RFIs, and any kind of changes. Then, the executive insight. I think we all know the importance of creating a simple metric through dashboards or analytics to quickly show if we are winning or losing. First, we will look at the development of the path of construction using Synchro. The main deliverable for this step is to create the most optimum path of construction, the fastest, safest, and most cost-efficient way to build your project. Typically, when developing the path of construction, we'll need a 2D plot plan, 3D models if possible, scoping documents, and target milestones. The benefits of doing this in Synchro is not only that you can see your plan visually, but you can also create different scenarios to come up with the optimum path of construction by detecting out-of-sequence activities. This allows you to resequence when they're required, improving the bad logic, and best of all, you can do all this in Synchro without leaving the application. Now we can start on the next step of setting up boundaries for EWPs and CWPs. EWP, an engineering work package, is an engineering deliverable that is used to develop CWPs and that defines the scope of work to support construction in the form of drawings, procurement deliverables, specifications, and vendor support that is released on an agreed-upon sequence consistent with the CWP schedule. CWPs are created by the project and construction management team in collaboration with the project owner in accordance with the established POC. CWPs are the backbone of construction projects. They are the foundation from which all construction activities are executed. CWPs should be discipline specific and facilitate early construction planning and logistic decision making. They are used to build IWPs that construction crews will use in the field. CWP boundaries should create containers of work that can be sequenced based on the most logical execution strategy. Once the path of construction is complete, you can easily create different 3D filters in Synchro to show the work area boundaries or show the boundaries of the multi-discipline CWAs. The same technique can also be applied to create 3D filters for each CWP discipline. You may also create different layouts to quickly switch between the discipline views. In this layout, we can easily identify all components that are in the work packages and the components that are not by using the color coding. The next steps are to extract the IWP from the CWP and link the IWP to the checklist items. We want to include 100% of the work necessary to complete the work package. At this stage, do not exclude any components, even if you know you have constraints that are not cleared. For example, missing drawings or materials. The goal is to create a proper grouping of components that makes sense for the field to install regardless of if you're seeing constraints or not. We also want to ensure we do not account for any component twice. In this demo, we'll take a look at how to create an IWP within the CWP boundary in Synchro. For this example, we are focusing on piping with carbon steel material. We can simply select a component from the 3D model. If we want to select entire isometric, we can simply choose from the properties provided. Then the next step is to add these components to the IWP. To estimate the number of man-hours required for this package, we can run an estimation script embedded in the application. In this case, the IWP requires 409 man-hours to complete. Next, we will export out the material list required for this work package. We will filter the IWP and select the task usage spreadsheet. Then we can export the material resources. We will save the material list file directly into the Synchro document repository, which is already synchronized locally within your desktop. The recommended best practice is that the files and folders are organized using the same IWP names. This will make searching and navigation easier in the next workflow. Now let's take a look at how we can use the Synchro form technology to connect your IWP to documents, drawings, digital workflows, and other required processes. We will select the form definition. In this case, we will select IWP. Next, we will fill out the required information to complete the form. Now we can select the assignee or a specific role for approval process within the IWP release plan. There are JHA and e-permit requirements in this process, which we will skip for now. We can select Add Files to link the documents stored in the Synchro repository to the IWP. Then we will browse and link the material list to the IWP that we prepared earlier. Synchro allows us to link more than one file to the IWP. In this exercise, we can also link the ISO drawings required to perform the IWP. Now we can start with our look-ahead and short-range production planning. Depending on the project, the typical look-ahead planning window is about 2 to 6 weeks. With the CPM engine in the back end, you can create different layouts and filters easily in Synchro to represent your short-range production planning process. With that said, we want to make sure we're incorporating safety into the planning as well, sequencing out any restricted work areas such as welding and lift areas, and removing any conflicting work. In this step, we will demonstrate how we can expose your EWP visually by increasing the transparency of the surroundings, and use the snippet to preview the location of the EWP in the model. This process is quite straightforward as Synchro knows what components belong to what work packs. Simply identify the inverse objects and select the color we want. Here you can see they are all grayed out now. We can now save and are all set. Once we save this to the cloud, we can click on an EWP and we will see the snippet from the web browser. One aspect of AWP planning is constraint clearances. The real value of the constraint clearance process is when it is performed during the look-ahead planning meetings. At this stage, you must already have your work packages complete and scheduled in the proper erection sequence. We can couple this with soundness management. Soundness management is the process to check whether the work packages are complete and ready for the field. As mentioned, a very important process in work packaging is the ability to review and check all constraints that may prevent the EWPs from being ready for the field. Having the full capability of CPM scheduling within the application allows Synchro users to create different filters to show the look-ahead planning or create short-range production planning using any date range we may prefer. Let's step back and review the material status for the piping. By using the color coding, we can see what materials are available and what materials are not. When using Synchro to manage the work package constraints, we will combine the short-range production planning window with the soundness index. Soundness index can be automated using Synchro script. In this case, we'll use it to read the material status information. Soundness can be calculated where, if soundness is equal to 0, then there are no constraints and EWPs are ready for the field. If soundness is greater than 0 or equal to 1, then the EWPs are not ready for the field. This is another helpful feature in Synchro where we are taking advantage of the CPM scheduling capability. We can easily show all the EWPs that are in the critical path, and using the soundness index, we can simultaneously understand whether the EWPs are ready for the field or not. Once all our work packages are ready to go, it's time to issue the CAN. How we complete the work. At this stage, we must have an EWP release plan and be able to easily track the installation work packages. We all know issues and changes can arise and need to be easily tracked and linked. In this Synchro demonstration, we can see the list of EWPs with all the critical information alongside, the package state and status, who created the package, when it is due, and who it's assigned to. We have full visibility as to where our project is at. We also have the workflow of approval embedded into the EWP process. We can go to our dashboard and filter our EWPs to show the different metrics. We can sort by who it was assigned to. Let's look at all the packages assigned to E1. Or by status, all the work packages that haven't been started. We can quickly switch to state and see open, close, draft, or jump over to the quick stats and see all the packages that are overdue. To execute the work in the field, we need to reference a variety of documents and information from a variety of different people who all have a variety of different job titles. As we all know, maintaining an effective and efficient means of communication can be very difficult. In this demonstration, we'll look at how we can execute our work packs in the field. We can see the EWP register in the web browser. We can select a work pack and it will identify that we need an e-permit to perform the work. When we set up an electronic permit system in Synchro, we can simply escalate the work pack to access the e-permit system. Many of the fields can be automatically pre-populated. We will define the start date and time of our permit, and we will fill out the rest of the required information. Now we can select the assignee and the due date to finish it up. This is one of the clever features in Synchro where we may create a hybrid map and 2D plan view of our project. We can assign the permit to a specific area, and in this case, we are assigning the permit to Area 3. Then save the form or submit the form to the workflow for approval process. The electronic permit register can be accessed from the web browser. Again, we can view all permits on the map. As we see, there are 3 active permit requests in Area 3. This should make the permit process more manageable, increase efficiency, and improve safety. Now that we have our permit, we all know the importance of prompt, accurate communication from the office to the field and vice versa. This can also be done with the direct connection between 40 Pro, Control, and Field. Control allows one central location for documentation, keeping track of drawing revisions and ensuring everyone is working off the correct version. Same goes for discovery work, submissions, RFIs, safety observations, and any other forms used in the field. This can all be done from a phone or a tablet at the job site and assigned to the responsible team member to get answers faster. We can also update work packages from the field. We can mark up drawings, taking photos and adding notes to help improve the plan for the next time this work must be done. Accurate progress tracking allows us to make more intelligent decisions about how we're going to move forward with our projects. It allows us to maneuver tasks, equipment, and manpower to ensure better control of our cost, schedule efficiency, and most importantly, safety. Getting accurate and timely updates can be tricky on projects. Coming from a planning and scheduling background, I don't have enough fingers or toes to count the amount of times I've had to chase down or verify schedule updates. In this demonstration, we'll look at how we can use Synchro for progress tracking. We can use resource statuses to help us track progress in the field, such as task % complete, material procurement, and field inspections. These are just a few of the construction workflows that resource statuses can help us visualize. First, we will need to create the resource statuses required for the project in 40 Pro. Next, we can assign the % complete to each status. Once we have our resource statuses created and set up, we can start assigning them to our resources and assigning the responsible team members to the work packs. Now that we have everything set up in 40 Pro, we are ready for updates from the field. Our team in the field can search for tasks assigned to them and update the progress from their mobile devices such as a phone or tablet. Once they select the task, they can choose from the material resource assigned to the task and update the progress accordingly. Once all the updates are complete, they can sync the updates back to 40 Pro for the scheduler or whoever is responsible for the schedule to update. Once the updates have been processed in 40 Pro, these updates will reflect in Synchro Control and the Field app for the rest of the construction team to view. As mentioned in Step 8, Field Execution, it is extremely important to eliminate the gap in communication from the office and the field. Having one central location for information and eliminating paper forms can majorly improve this. A study done by FMI Big Data revealed that on average, we spend half a day every week looking for data or information. And with that, we only use 4% of the information available, leaving 96% unused. One thing that used to drive me nuts in the field was the amount of time wasted when requesting for information, getting ping-ponged back and forth. Majority of the time, this was due to each side not providing enough information on the initial requests. Supplying all the required information from the get-go can save valuable time and money. Now, let's look at how we can use Synchro to manage issues that we have found in the field. For this example, we have an issue on the drawing in the work package. We can easily find the work package by using the filter option. Now we can open the work pack and see the drawing attached to it. The drawings can be found in the attachments list. Once we find the drawing we are looking for, we can open it in the markup mode.
Here, we can add a cloud around the issue on the drawing. For the example on this drawing, the routing of the piping is incorrect. Next, we can create an issue directly from our markup, and we will give the issue subject name the same as the workpack name. I will copy and paste the workpack name, fill out the description and other information like issue type, issue priority, and assign it to the correct person with a due date. Now the issue has been created. Next, we can link this workpack to the issue. With this, we will get the complete information for this whole workpack. We can also digitize inspections, allowing inspectors to complete inspections from their phone or tablets, easily adding documents, pictures, and videos in real time. No more having to go back to the office or to the computer to transfer information and create separate inspection reports. During construction projects, we take hundreds, if not thousands, of photos. The newly released Media Explorer, Synchro's media indexing solution, allows us to easily locate photos. The first way these photos are indexed is based off of date and time the photos were taken. As you can see here, we can search off predefined time ranges, or even set a custom time range we know the photo was taken. Next, we can locate photos off of content. Synchro can search based off of content of what is in the photo, based off an AI machine learning algorithm. For example, I want to see every photo with a vehicle. So I would search vehicle, and as you can see, it has filtered every photo that it recognizes a vehicle in. Now we can search by context, full object character recognition of text. As you can see here, Synchro is able to recognize text and words in the photo. You can search these words and Synchro will locate any photo that has them. If we click on the map, you can see we have photos located all over the US. Synchro can also index based off a location. It will locate photos based off a geospatial map location from the photo. As I scroll in, you can see the blue dot indicating how many photos are in this location. If I hover over the dot, I can scroll through the photos, then select the required photo. As you can see, it lists the source the photo is associated with. With these multiple ways of indexing, it makes it quick and easy to locate the required photos. Executive insights and schedule analysis should be easy to distinguish if you are ahead or behind. The schedule health analysis can be portrayed numerically or visually to give a prompt overview, allowing the team to make fast and informed decisions on how they need to move forward on the project. In Synchro, we have a few different ways to reveal this information. First, we can easily create animations. In this demonstration, we will create a plan versus actual animation in Synchro, clearly identifying if we are ahead or behind. In the animation editor tool, we can create custom templates, adding multiple 3D views, Gantt charts, timelines, and if we really want to get fancy, we can even add music. Once we have everything set up to our liking, we can export and share the animation with the rest of the team, giving them a clear visual of the schedule and the progress of our project. Next, we can import the information from Synchro into Power BI or other dashboard solutions. As we can see in the first example here, we have created a 4D playback using snapshots from Synchro. Now, we have an interactive dashboard showing the budgeted total cost based off the resources and time ranges. Here we have created a nice visualization of the concrete production on our project, making it easy for everyone to understand the progress to this point. And finally here, we'll take a look at Synchro Perform for project executive insights. The home screen gives high-level oversight to various activities on the project, attendance, and labor summary. Moving on to progress tracking in Perform, you can see our IWPs for piping have gathered progress over time. And here we can review at a granular level our planned and actual percentage complete, as well as remaining scope. Drilling deeper into progress activities, we can see a specific entry and all the related IWP information. Finally, aggregating all the IWP progress data, we are able to generate real-time dashboards that demonstrate our S-curve for labor and value in this instance.
The S-curves leverage the budgeted, planned, and actual progress for the IWPs to generate true project executive insights into the health of your project.